In this tutorial, I'm going to be going through the process and simulation of a computer adaptive test. Computer adaptive testing is a computer-based test that is based on IRT theory. It is able to provide a questionnaire to a test taker that is tailored to their ability. The questions are chosen for the test taker as they are taking the test, depending on the difficulty and the discrimination of the questions they are answering. Depending on the questions they answer and their ability, they may not have to take the whole test, but that depends on the parameters that are set for the test. In my example, I'm going to be running a 2-parameter latent trait model, and that means it has the 2 parameters for each item, the difficulty and the discrimination. These items can be answered either correctly, which is indicated by a 1, or incorrectly, which is indicated by a 0. So I'm going to get started, even though I've already installed and libraried my packages. The package that I'll be using is the cat-r package, and this is that runs enables me to simulate and run a computer adaptive test in R. So it's already installed, but I'm going to go ahead and run it and library it again. So that just gives me access to the package. My first step in creating this simulation is going to be to randomly generate the test bank of items. And so in order to do that, I'm going to use the GenDyco matrix function, and I'm going to save it to the object bank. The arguments that I'm going to use for this function is going to be, I want it to create 500 items using the 2PL model, and here I'm setting the seed to 1. This is really helpful since if I want anybody to replicate my findings, I need to seed this. So the 2PL model, I just want to review this really quick. These 2 parameters, the discrimination and the difficulty, A is discrimination and B is difficulty. So I'm going to go ahead and run this, and this is going to generate my item bank, which the computer adaptive testing will pull the items from. So I'm just going to run this, and you see now I have the data. I have 500 observations of 4 variables. So I'm just going to take a look at that, which is here, and you see that I have variable A and variable B. C and D are just are set. Those are really for a 3 or a 4 PL model. You can see that C in this example, C is set to 0 and D is set to 1, and that just means that those variables are fixed. So I'll only be concerned with A and B for this example. So now I have my test bank. My next step is going to define all the parameters for my my computer adaptive test, or CAT for short. And to do this, I'm going to create a bunch of lists. The first list that I need to make is my start list. So I'm going to save this list to the object start, and this is how this list defines the parameters for the first item. In this case, I'm indicating that it can indicating the start item be randomly selected, just one item, and which has a difficulty level near the ability of 0, 0 being the mean. So this would be the parameter for my first item. Next, I'm going to create the list for my test item. So I have my test object and the list that I'm saving to that object. So the test list defines how to choose the next question, but the first or more questions already have to be answered. So the method that I am using is the Bayesian modal estimation to estimate the scores and to select the items with the maximum Fisher information criteria. The next thing that I need to indicate is when the test will stop. So this list I'm going to save to the stop object, and the rules that I'm using to indicate when for the test to stop is both precision and length. And the threshold that I'm using for precision and length in order is important here. So the precision is, I have 0.03. The precision, so, and the length of the test is 25. So the precision I have is 0.03, but I really want it to be 0.3. So I'm going to change that. I'm glad I hadn't run that yet. So when the precision criteria falls below 0.3, and that is estimated by using the standard error of the provisional ability estimation, or if it reaches the length of 25. So that's two stopping rules. And then the last list that I need to make for my simulation is the final object. So I'll save this list to final, and the final object list, this list defines the method that I want the cat to use to estimate the final ability. So in this case, I'm using the Bayesian modal again. So those are all the lists that I need to run my simulation. So I'm going to go ahead and run these, and it just creates a bunch of objects over here with the list you see here in my global environment. So my next step is to simulate the cat. And so what I've done up until this point is set up the parameters to simulate a 25 item test from a 500 item bank. So for this, I'm going to use the random cat argument, and this is going to hold all of my parameters. I'm going to hold it in this result object. So in my example, I am indicating that to simulate a cat example with a true ability of 1, and that's 1 standard deviation above the mean. For the item bank, I'm using the object bank that I created, randomly generated above. Model will be set to null. If I was using a 3PL or 4PL, I could indicate that here. The start object, I will be using the start list that I created. For test, I'll be using the test list I created. For stop, the stop list I created. And for final, the final list I created. So I'll just run that. It creates my test. I'll use the result. I'm just going to print the result, and to do that, I can just run result. And it gives me a pretty detailed output. So in my example, what this has done is really only simulated the response pattern for one individual. So in an applied example, this may be an individual that took a test, a cognitive ability test for selection. Another way to use this is to see if your how your tests and your items are working. These adaptive test details specifically tells me what item they got. So they took, in this example, this is all 25 items that the test taker took. It says here that the item that they started with was 343. they got it right and estimates their ability at 0.589. And it moved on to the next question, and they also got it right, and the ability estimate went up. The next one they got right, and the ability estimate goes up. So it continues on for 4, 5, and 6 they got wrong. For 7, 8, 9, 10 they got them right. And so these estimates continue to go up and down depending on what they get right and what they don't. And their last one they got right, they have estimate, the ability estimate for this answer was 1.54. So this also tells me that the satisfied stopping rule that they got was the length of test. So not the criteria set, but the length of test. They got, and this is just some more details about what it ran. The final ability estimator. Here it's telling me that the final ability estimate is 1.54, which is actually higher than what I indicated with the truth data of 1. And the ability estimate was getting close. I mean, the criterion estimate was getting close. So if this was in my applied example, if somebody took this test and this was the result that I got, then I might pass them on to the next phase of selection because they did really well. They scored higher than the cognitive ability that I indicated. And if I wanted to talk about the results and what a person may go through while they're taking this test as in a simulated CAT situation, and maybe explain it to my team or my supervisors. I could also plot these results and visually see how the individual went about answering them. So here you see on the bottom is items, the 25 items they went to, and the ability estimate going from 0.4 to 1.8, 1 being the ability that I outlined in my random CAT that I wanted it to estimate to. So you see they started getting their first question was down here at the 0.6 area, and then they continued to go up. Then when they reached the third question, they started getting the 4 wrong. So this is actually just a visual representation of the adaptive test details over here. So thank you very much for watching.